All right, so here's another example of a chemical reaction, photosynthesis. And the thing to remember when chemical reactions happen, the things that go into the reaction, so the reactants, they're not created or destroyed in a chemical reaction, they're just rearranged, right? So what you're going to see is that whatever goes into a reaction, you have to make sure that the same amount of atoms come out of the reaction, right? So the amount of atoms in the reactant side has to equal the same amount of those same kind of atoms on the product side. I know it sounds a little confusing, but I'll clarify that right now. So an example of a chemical reaction is photosynthesis. And here you kind of just see just visuals, right? Like a visual example of that. You have the sunlight going in, you have the CO2, which is a carbon dioxide, you have the H2O, which is water, right? And then coming out of there, and there you see the molecules of carbon dioxide. They should have put H2O molecules, but they just put a puddle of water. And then you see those are the reactants. So the products that come out of photosynthesis are oxygen and sugars. And what you're going to see in a little bit is that whatever goes into the reaction, the same amount of atoms have to come out of the reaction. So here you actually see the formula for photosynthesis, right? So you have the reactants on the left side of the arrow, and you have, so the reactants over here on the left side of the arrow's right here, and then the products on the right side of the arrow, right? So this right here is basically this picture right here, just drawn out into numbers and words instead of using images. So here you have carbon dioxide, here you have H2O, and sunlight, right? Those are all the reactants that go into photosynthesis. What comes out over here on the product side is glucose, C6H12O6 plus oxygen. All right, so what these numbers though are telling you right here is that there are 6 molecules of carbon dioxide, 6 molecules of H2O. If you don't have a number in front, and these numbers are called coefficients, and we'll see that in a little bit in more detail. If you don't see a coefficient in front, a number in front of it, you just assume there's a 1 there. All right, so here in front of C6H12O6 or glucose, you just assume there's a coefficient of 1 here, so there's just 1 molecule of glucose. And then here this 6 is saying that there are 6 of these oxygen molecules. Right, so here, and then this GIF right here is just photosynthesis, right? Whenever you see green on plants, that means that photosynthesis occurs in that part of the plant, right? So again, the important part to remember is that whatever goes into the reaction, so the reactants, you have to have the same amount that come out in the product side, right? And this is what I was saying earlier, is a conservation of mass. So we're going to go back to that photosynthesis slide in a little bit, but just remember this, the law of conservation of mass. So this is just what I was saying, is that the conservation of mass means that matter is neither created nor destroyed during a chemical reaction, right? So you don't create it, you don't destroy it, you just rearrange it, right? Many atoms go into a reaction, and that's how many you will have in the product. So here in this image right here, you have coal and oxygen, right? You have C and you have O2. And then they go through a reaction, and what comes out is carbon dioxide. But you see, you have one of these carbons right here and 2 of these red oxygens. When you get a product over here, you have the same amount, they're just rearranged, right? So you have the carbon and you have the 2 oxygens attached to that carbon. So the same amount, right? 1 carbon, 1 carbon, 2 oxygen, 2 oxygen. They are not created, they are not destroyed, they're just rearranged. And this is very important right now when it comes to balancing chemical reactions. And that's what we're going to be doing, is just making sure that whatever the amount of atoms you have going into a chemical reaction, you're going to have the same amount coming out of that chemical reaction in the products. Right. So again, this is just what we talked about, these chemical reactions. I'm going to go into a lot of detail again because we saw this slide earlier, but just going back to these chemical reactions, right? So you have that chemical reaction, and in order to put that down in a way that we can balance this, we have to write it into an equation. All right, so balancing chemical equations, right? I just kind of show you how to account for atoms on both sides of the arrow. You're basically just multiplying the coefficient by the subscripts, right? So balancing the chemical equations, though, there's a little bit more to it than that. So you're going to have to change coefficients in a chemical reaction so that the same number of atoms of each element are on both sides of the equation, right? Or on both sides of the arrow. So here are the steps. If you all ever are having problems with this, one of the first things I'm going to ask you, if you ask me for help, is have you followed the steps to balancing an equation? And if the answer is no, then I'm going to say go back and follow the steps. And if you do that, it's going to simplify things a lot more than if you just kind of try to go all over the place, right? So these things are numbered for a reason, right? So you follow them in order. So these are the steps to balancing an equation. First off, you have to write the chemical equation, right? And so an example again of a chemical equation is like this photosynthesis equation at the bottom. 6 CO2 plus 6 H2O yields or gives you 1 molecule of glucose and 6 of oxygen, right? So that is the chemical equation, and that's what you would write down. Then the next thing you're going to do is check for an atom balance on both sides of the arrow. So you're going to check to make sure that you have the same amount of each atom on both sides of the arrow. And then once you do that, you're going to have to choose coefficients that are going to balance the equation. So basically, you're going to see if you have the same amount of, for example, oxygens on the left side of the arrow as on the right side of the arrow, right? And so if you don't, you're going to have to change the coefficients so that they do balance out to the same number. And then you're going to recheck the numbers of each atom. Just remember though, when you're balancing equations, you can never change the subscript, but only the coefficients, right? If you start messing around with the subscripts and start trying to change those, then it's going to be very confusing. Remember, you cannot change the subscripts. You can only change the coefficients. Just remember that while we're working out these problems. And so now we'll see a few examples. I'll work out a few problems. And just make sure that you're following along. Remember, you can pause the video. You can rewind the video as many times as you like, right? So make sure that you get this concept down because you will see it in the final.